Hello, good morning everyone. Today is our second video on this channel, and today we will master the 4 different learning methods of machine learning. These will be our today's agenda. We will learn what is machine learning, what are the different kinds of learning, which are supervised, unsupervised, reinforcement, and semi-supervised. When should we use what in what specific task should we use what kind of learning, and the final conclusion and Q&A. So first of all, let us understand what is machine learning. You will see machine learning is a subset of AI that enables systems to learn and improve from experience without being explicitly programmed. Now, what does this mean? Imagine a children. You will see as the children grows adult, it learns and adapts from its previous experiences, which he has experienced in the environment. Machine learning also works in a similar kind of fashion. Now, how does that happen? We do not give any specific hard-coded rules. There are no rule-based learning which happens here. It adapts, the model adapts and learns from the previous data points on which it has been trained on the environment, whether it could be a labeled data or it could be unlabeled data. Now, what are labeled and unlabeled data? Obviously, we will learn in the next slides or the next few videos. But for now, just understand is that labeled data, unlabeled data, both are used to train the model and understand what specific task or what specific scenario are we talking about, or are we letting the model to learn. And based on that, it predicts different kinds of things. It can predict a classification or understanding whether an email is a spam or not. It can give us a rough range on what could be the temperature of next day, a stock price prediction, many different things. So this is just the basic understanding of machine learning, is that it's just a subset of AI where we enable it giving the proper data to learn and improve from past experiences and environment for future predictions. Got it? Now let's talk about what is supervised learning. This is the most basic and the most fundamental type of learning in machine learning. It trains models on labeled data to predict accurate labels for new inputs. Now, what is labeled data? Let us understand what is labeled data. So suppose you have pictures of dog, you have pictures of cat, and you have pictures of, suppose, rabbit, right? So suppose these are the pictures of dogs, these are the few pictures of dogs, these are the few pictures of cats, and these are the few pictures of rabbit, right? So what happens in label data is, please excuse my drawing, I'm not good at drawing, but yeah. So what happens is label data is we have labeled this, right? Each column has a name. So when we feed the model this data, the model already knows that if it sees images like this, B, there is already a mapping to the dog, right? There is already a mapping to the dog column. So it becomes very easy for the model to understand that if a new dog image arrives, it quickly understand where to put it, right? This is the unseen data. This is the test data, which we will be feeding the model after it learns from this whole thing. After learning from this whole thing, if we give a data like this where it already know that if the animal looks like this, it will already be going to the dog column. So it becomes much easier and faster for the model, for the supervised learning model, to understand where will the new test image will go. Fine. So let us understand the theoretical part of it. Providing labeled data. The algorithm learns from a labeled data set. Each training example pairs input with the correct output, right? So here we are seeing that we have to provide label data. So what does that mean? The algorithm learns from a label data set. Each training example pairs input with the correct output. Like each feature has a label or a target column, right? So which is already predefined by the data. This helps the model to correctly classify, or on any kind of data where it is labeled, it is able to correctly classify each column based on, as I have said, the dog, cat, rabbit, that example. It learns mapping function. The goal is to learn a mapping function from inputs to outputs so it can predict labels for new unseen data. As I have said, for the new unseen data, it becomes much easier for the model to understand what it is trying to predict, and based on that, it predicts on what column the new data would go. Train the model. Train on labeled data, the model learns patterns, predicts on new unlabeled data, and measure accuracy against known answers. Now, what does it means by accuracy? Suppose we are giving around 10 new unseen data points to the model to understand, learn, and classify based on those learning. Now, suppose the model is able to predict correctly 9 samples. One sample, probably it could be an image of a different breed or of a different animal or anything like that. So suppose it is able to predict 9 examples correctly. So what could be the accuracy? Yes, it's 90%. Fairly easy. So then we predict and evaluate. Use the learning map to predict labels for new features and measure the performance against true labels. We measure the performance, like how it is performing against the true labels. Like suppose we have already few seen data that we have already presented to the model learning, right? So when we are using the unseen data to understand what is happening, we compare those two sides of data, two percentages of data, to understand how well the model is actually performing. Is the model just remembering the past learning, or it is actually adapting to the past learning, to the patterns, to the like outlines, everything, and understanding how to correctly classify the new data points, whether they are same or not. Next, let's move on to what are the core tasks that we can do from supervised learning. First is classification, which I am saying up till now. Classification, it predicts a discrete category. So what does that mean? It predicts whether an email is a spam or not. You will obviously see in your mail that some important mails are not in the spam folder, while some mails automatically go into the spam folder. Why does this happen? It happens because of supervised learning. It happens because it classifies both mails into correct categories. It predicts a discrete category. As I have said, is this new image an image of a cat or a dog or a rabbit? It correctly predicts. We use algorithms like logistic regression, decision trees, random forest, SVM, and neural networks. Now, don't get overwhelmed hearing those algorithms. We will obviously learn about each and every single algorithm in the upcoming videos. Next is regression. What is regression? Now, regression is a little different from classification because it predicts continuous variables. Now, what are continuous variables? Now, how are we predicting continuous variables? Let me give you some examples. Suppose I want to know what's the temperature for today. My model cannot just say tomorrow's temperature will be hot. Like, does not make sense, right? Suppose on that part, what our model can do, it can give a range. Suppose tomorrow's temperature would be from 30 degrees Celsius on the low side to 36 degrees Celsius on the high side. Now, this gives me a proper idea about what can I expect from tomorrow. The range gives me a proper idea. This range is not a classification range. It's a continuous variable. The temperature can vary from 30 to 36 in any given numerical float number, right? So this is how it gives us a range or a continuous value. We can also use it to predict what could be the average price of a house, or how we can predict a stock price. Here, models include linear regression, polynomial regression, boosting, bagging, etc. What are the real world use cases? Some real world use cases are fraud detection, medical diagnosis, customer churn prediction, and stock price prediction. Next, let's move on to what is unsupervised learning. Now, some of you may have this question that real world data is not labeled. It is not already labeled. We take the data from a certain database, right? So that database may or may not have already classified the data that we are taking. I have just used examples of cats, dogs, very preliminary tasks. But when you are working for a company, taking data, extracting data from that database is not never going to be labeled data. It is going to be unlabeled data. Now, what is unlabeled data? Let's understand what is unlabeled data. Now you will see that suppose if I take the same example, is like there are different pictures, right? Suppose now you may notice that these pictures are distributed. There are no particular columns, right? This could be the dog, this could be the cat, this could again be the dog, this could be the rabbit, this could be dog, this could be rabbit, this could be dog, right? But these images are not labeled like this, like the cat, dog, rabbit, as we have mentioned here. So this is how real world data looks, right? This is how real world data looks. I'm sorry about sorry, let me just write it here correctly. Real world data, right? So from this, we need to first classify these data points into correct columns. We need to first, by using different algorithms, make this data look like this: dog, cat, rabbit. Means we need to use algorithms to convert those unlabeled data into labeled data points for our model to understand. This is unlabeled data, right? So let us understand what is unsupervised learning. The algorithm works on labeled data and aims to discover the inherent structure, patterns, or groupings within the data itself. What does it mean? As the algorithm works on unlabeled data, there are no particular columns, there are no particular classification for each image, as I have mentioned. We need to properly understand what each image or each data point means. And based on the structure of the data, we need to correctly classify the pattern or grouping within the data. Within the data points, we need to particularly classify each data point. Now, there is a key question. What can we learn about the data without any instructions? Because there are no instruction now. Here, instruction means obviously the label data, the label which we are talking about. There are no instruction given to us. It's just a bunch of data points scattered around the whole database, right? So for understanding, for visualizing, right, we use exploratory data analysis. Now, what is exploratory data analysis? We will understand it in upcoming videos. But for now, understand that it's a data visualization tool where we use different kinds of visualization plots like box plots, scatter plots, line plots, bar charts, etc., to properly understand how each data point is present in the database. It also helps us to properly cluster or group each data point by visualizing or understanding what is happening in the whole data. What are the key techniques? First is clustering, grouping similar data points together. Like, what does clustering means? Let's see what does clustering means. Let's go to a new page. Yeah, whatever. Like, suppose these are one kind of data. These are one kind of data. And these are one kind of data, right? What clustering does is, if we just give these to the model will not understand what is these patterns, because these can go, after then these can go, after then these can go. So the model will be confused. What clustering does is, it understand the inherent structures, and based on that, it develops a cluster around each data point, similar data points. You understand that these points are similar, right? These points are similar. In the same way, these points are similar, right? Now you may notice that I have also added these data point, this circle data point, into the square one. Now it is a clustering cannot be 100% correct. It will incorrectly classify a few data points. This is completely normal as long as the bigger picture is clustered properly. Now we have clustered. As after we have clustered, we can do this: triangle, circle, and square, right? And the clustered data points of triangle will be put here, the circle will be put here, and the square will be put here. What happened here? We have just transformed an unlabeled data to a labeled data. This is how clustering works. It's simple, but it will take a little bit of time for you to understand. But once you do, you will fall in love with clustering. Let's move on. So let us understand what clustering means. The examples, it means grouping similar data points together, as I have mentioned. The examples include customer segmentation for targeted marketing, document topic organization to group similar text for search and discovery, basically search engines, which Google uses and different platforms also use. Image compression by grouping similar pixels or patches to reduce storage size, right? Algorithms which clustering includes are k-means, hierarchical clustering, density-based clustering for different data shapes and densities. What is association? Discover rules that describe relationship between variables. Now, what does this understand? We need to specify rules for associating different data points and grouping them together. What are the examples? Examples could be market basket analysis to find products frequently bought together. Like if one product is bought, what are the chances that the different product will also be bought? It means a pair will also be bought. Many of you will observe that when you will buy milk from Amazon, when you are almost around buying the milk carton or the milk packet, you will see that in suggested products they are going to show bread, eggs, and bananas too. Now you may wonder, milk is a dairy product, how is a fruit showing based on the similar cluster on a similar kind of products? These is because it's a different kind of grouping. Now these kind of grouping happens based on what customers already purchase. Now if you're buying milk, there are high chances that you are going to drink it for breakfast. Now in breakfast many people take eggs and bread and obviously fruits too, which are completely fine, right? So based on that matter, this is what is happening. It is grouping the data, grouping the milk along with close relationship to the other three products. This is how market basket analysis works, and this is what Amazon, Flipkart, Zepto, Blinkit, different kind of um, e-commerce websites use. What are the algorithms? Algorithms include a priori for frequent item set mining and rule generation. Algorithms also include ECLAT as an alternative approach and identifies frequent co-occurring items to drive cross-sale and recommendation strategies, right? And the last one is dimensionality reduction. Reduce the number of features while preserving important information. Now, this is mainly used for moving high dimensional data into low dimensional data and grouping it together like that. It is mainly used for visualization to project high dimensional data into 2D or 3D plots for insight, because we cannot really plot 4-dimensional and above of that. So we need to properly scale the data down so that we can understand how the data is working. It is used for noise reduction by removing irrelevant or redundant features. We remove irrelevant or features that are not really important to our tasks, to a specific task only. We remove those features. It is used for feature extraction to extract important features from the data, which are mostly able to classify or for our own task. It is able to classify. We can use dimensional reduction for that. There are algorithms like sorry, where did it go? Yeah. Their algorithms include PCA, which is principal component analysis. There are LDA, which is linear discriminant analysis, and TSNE for linear and nonlinear embedding, respectively. Let's move on. Now, many of you have heard of robots, right? This is the learning which happens inside that. Now, what is reinforcement learning? Here is an agent. And as I have mentioned in the first slide or the second slide, I don't remember actually, I have mentioned that the machine learning concept, it understands from the environment. But up till now, we are only giving data, labeled data, unlabeled data, whatever it is. We were giving data to the model. This is the first time where it actually learns from the environment. So what happens? There is an agent. The main task of the agent is to understand and perform actions based on what is happening in the environment. It is based on a reward strategy. It learns from trial, error, and feedback rather than label data. Now, let me make you understand how that happens. Suppose a robot. A robot is moving in one direction. And every time it moving in one direction, it faces one obstacle, due to which it is completely the motion of the robot is completely getting stopped every time it goes in a straight path. After some trial and errors, after some iterations, the agent will understand that after moving this much distance, there will be an obstacle present. And based on that, what it does, it is, suppose it goes up to that distance, and once it triggers in the brain of the agent that obstacle could be present in front of me, and my main task is to move in motion completely, it will completely avoid the obstacle and move forward. This is how a robot works. A robot is not controlled via a remote of its movement or its talking. It needs to understand its environment. It needs to understand what obstacle it is facing based on the target, or the learning based on the target which it is performed to do. And every time it makes a right decision, a reward is given to, a cumulative reward is given to the robot or the reinforcement learn method, so that it gets motivated to further learn from the environment and make correct predictions. What are the key components? The key components are the agent, the learner or the decision maker, the environment, the world the agent interacts with, action, what the agent can do, and the state, what is the current situation. What is the reward? The reward is the feedback from the environment that guides learning and decision making. What is the reward? It is the feedback which is it's getting from the environment that guides learning and decision making. What was the feedback in the example that I have said? That the model or the robot is not having to stop its motion, and it is completely able to go from a point A to point B without facing any obstacles. That is the reward which motivates the agent to further learn in any more obstacles. What is the process? First of all, the agent needs to observe the state, the initial state of the model. The agent needs to understand. Then it needs to understand what action it needs to perform. Does it need to talk? Does it need to do any math? Does it need to move from point A to point B? Agent chooses an action based on the policy which are given by us. What is the environment transition? Environment transitions to a new state. Here, the environment helps the model to understand that if the task that is given to us has any obstacle or any other kind of problem present. And based on few trial and errors and based on the feedback that it gets from the environment, the agent correctly understand what is the problem that is happening or what other kinds of obstacles present, and based on that it receives a reward from the environment. The as I have previously mentioned about the about the reward receiving, after that it updates its policy. Agents update its policy to maximize future rewards. What does that mean? First time that it correctly predicts, it goes up to the point of the obstacle. It thinks that maybe this obstacle is going to slow my motion, and then it ignores the obstacle and move forward. But after first time, when it receives the reward from the environment, the feedback reward from the environment, next time it is not even going to go in the straight path. It is going to go like this. Time decreased and the model still goes to the target B. So this is how it maximizes the reward. And this loop repeats every time until it optimizes correctly, until it moves in the shortest amount of time from point A to point B. Now, these is the, like, what can I say? Most people will not make you learn about this kind of learning. It is semi-supervised learning. What is semi-supervised learning? It is an interesting concept. Semi-supervised learning means it harnesses both the power of supervised and unsupervised learning. Now, what is that? Semi-supervised learning has a very small amount of label data, like around 10%, 20% label data. And using those label data, leveraging that label data, it correctly labels the unlabeled data, or the 80% of data which is not labeled. You will see here written, semi-supervised learning uses a small amount of labeled data together with a large amount of unlabeled data to improve model performance when labeling is expensive or time consuming. Suppose, let me show you what I'm trying to say. Okay, let's go to a new page. So suppose I have around 5 million data points, right? 5 million, and I want to perform clustering. The clustering algorithms which I have mentioned, k-means, hierarchy, well, these two I am saying. The data set is very large, right? So there could be a lot of data points, right? 5 million data points is not less. And if your machine is on the low end, correctly classifying this whole data is next to impossible. It will make your machine go slow. It will not correctly classify in a less amount of time. Means what will happen? Time got increased, computation increased, right? So overall, what increase? Cost increase, because the data set is very large. So what we do is we take a subset of this data, suppose 1 million, right? And on this, what we do is we do sampling. Now, what is sampling? We will understand in next videos, obviously. So now this is 20% of the total data, right? This is much less data than this one. What we do is we sample on clusters of data points on these data. Now these become label data after clustering. And based on these label data, we classify these 4 million means, or the rest 80% of the data is classified, right? So what happened due to this semi supervised? The time decreased, these decreased, cost also decreased, right? So let us understand theoretically what is happening. How it works: the algorithm leverages pattern in the unlabeled data to generalize better from limited label examples, influencing decision boundaries based on this data distribution. Now what is decision boundaries? Decision boundaries means, right? So decision boundaries means, suppose these are one kind of data, these are one kind of data, a boundary between them which separates both data points. These are the decision boundary where new data when comes square, it falls on this, and circle it comes, it falls on this. This is the decision boundary, right? Use cases. Use cases include speech analysis, web content classification, and protein sequence classification, right? A visual description where a data set with a few label colored points among many unlabeled gray points showing decision boundaries influenced by unlabeled data distribution. Let's move on. When should we use what kind of approach, right? If you have label data, use supervised learning and choose classification for categorical data or regression for numerical data. Classification give categories and numerical or continuous variables where we have talked about ranges in numerical data. We use regression for that. If you have, sorry, let me just move this. Yeah. If you do not have label data but have an interactive environment with rewards, use reinforcement learning. What does this mean? If you do not have label data, if you have label data, supervised learning, that's it. Yeah. But if you do not have label data, you have unlabeled data, but you are able to interact with the environment. When what do we use there? We use reinforcement learning. If you do not have label data and interactive environment, use unsupervised learning to explore the structure, the pattern, or the overall data point grouping correctly. We use unsupervised learning. Here, no labels and no interactions, explore patterns with unsupervised algorithms. If you have a little bit of label data and a lot of unlabeled data, use semi-supervised learning. What does this mean? If you have a little bit of label data, now, as I have mentioned, we are making the label data there, right? But what you can, there are many different data CSV files or Excel files also, where you will see that a small amount of data is already labeled for you. It is already clustered, associated for you. And based on that, you are going to predict on the unlabeled data, right? What the problem here? So, what are the key takeaways or conclusions that we got from this? How different approaches shape model behavior. Supervised learning maps inputs to outputs with labels. Unsupervised learning finds the hidden structure behind the unlabeled data points. Reinforcement learning optimizes behavior to environment via the rewards it gets from the feedbacks. And semi-supervised learning combines both labeled and unlabeled data to bridge the gap. Advanced systems often combine these paradigms. So, basically what this is saying that in advanced systems we can use multiple learning algorithms in a single task to properly optimize our output. So yeah, that's it for today. So yeah, that's it for today. I hope you understand the 4 different kinds of learning that I was meant to for make you understand. In further videos, we will understand what are the different kinds of what is structured data and unstructured data is going to be our next topic. So I hope you enjoy this video. Subscribe to my channel. See you in the next video. Peace.